Okay, so ladies and gentlemen, you are welcome. So in this video, we are going to solve physics 1 to 2 first question paper, and we are going to start with question 1. So this is one of the question from some first question paper. So we are going to answer it. The question says a charge of 28 microcoulomb has an electric field intensity of 4.3 times 10 raised to the power of 3 volts per meter at a distance of 2.3 centimeter. What is the electric field intensity if the distance is double? So I think without wasting much of our time, you can see that, remember, ladies and gentlemen, when you said electric field intensity is the something as K Q all over R square. So this is the formula for calculating electric field intensity. So the first thing, we now need to bring the data. We need to bring the data out. So number one, we have charge. We have charge here as Q, or let me just write Q. We have Q here as 28 microcoulomb, and don't forget that micro is something as 28 times 10 raised to the power of minus 6 coulomb. And then the next thing is the electric field intensity. The electric field intensity is given as 4.3. It's given as 4.3 times 10 raised to the power of 3 volts per meter. And then the distance, that is initial distance R1, is equal to 2.7 centimeter. And then the second distance, which is R2, is the same thing as, because the distance is doubled. So if the distance is doubled, it means that we are going to have 2R. We are going to have 2R1. So that is why here we have 2R1. And if you want to get the value, you can now say 2 times 2.7 centimeter, and this will give us 5.5 centimeter. So we have this. So if you look at the questions, actually we are trying to get electric field intensity. So remember, ladies and gentlemen, electric field intensity, let's say electric field intensity E1 is the same thing as K Q all over R1 square. And then for the electric field intensity 2, that is electric field intensity 2 is equal to K Q all over R2 square. And remember, R2 is 2 times R1. So therefore, we can now say electric field intensity here, E2 is now equals to K Q all over, so R2 is 2 times R, or is 2R1. So we can now say 2R1, then we can now square it. Meaning that now E2 is equal to K Q all over 4R1 square. So we have 4R1 square. And don't forget that E2 is equal to, we can now see 1 all over 4 times KQ times KQ all over R1 square. And look at it. E1 is equal to KQ all over R1 square. So here we also have KQ all over R1 square. So this means that this one is the same thing as, so as we can see, ladies and gentlemen, the KQ R1 square is the same thing as this. So we can now see this one is now equals to E1. So therefore our formula is now E2 is equal to 1 all over 4 E1. So this electric field intensity 2 and this electric field intensity 1. So therefore, to get E2, we already have electric field intensity here. So we are now going to say E2 is equal to 1 all over 4 times the electric field intensity here is 4.3 times 10 raised to the power of 3. So if we now take our calculator, 1 divided by 4 times 4.3 times 10 raised to the power of 3, it is going to give us 1.075 times 10 raised to the power of 3, which is the same thing as 1075 volt per meter. So this is the answer. So this is our electric field intensity 2, and this is of course the E1. So I think, ladies and gentlemen, we can see clearly the answer here is option D. I hope you understand. So now let's also answer another question. So this is another question. A point charge of magnitude 2 microliter is moved through a distance of 0.5 meter against a uniform field of intensity 25 volt per meter. The work done on the charge is A 5 joule, B 5 times 10 to the power of minus 6 joule, C 1 times 10 to the power of minus 5 joule, and then D we have 10 joule. So this is the question now. So now let's actually bring the data solution. So we now bring all the data. So we now have a point charge of magnitude. So we have Q here. The Q is equal to 2 microcoulomb, and 2 microcoulomb is something as 2 times 10 raised to the power of minus 6 coulomb, because micro is the same thing as 10 power minus 6. And then apart from the Q, we also have a distance. We have a distance D is equal to 0.2 meter, and then with a uniform electric field intensity E is equal to 25 volt per meter. So the work done, in this case we are going to calculate work done. And don't forget, ladies and gentlemen, remember that force, or let me say electric field intensity is equal to force all over Q. So to get force, we are now going to make this subject of F subject of the formula. So by cross multiplication, this one time this is going to give us EQ. And then we already have E from the question is 25. And then we have Q, which is 2 times 10 raised to the power of minus 6. And at the end, when we take this and we multiply it with this, is going to give us 50, of course. 50 times 10 raised to the power of minus 6. As we can see, 25 times 2 will give us 50. And this is Newton. And then, of course, remember, work done is equal to force times distance. So therefore, we are now going to say 50 times 10 raised to the power of minus 6 times the distance is given as 0.2 meters. So when we multiply this and this, it is going to give us 1.0 times 10 raised to the power of minus 5 joule. So therefore, the answer is C. So ladies and gentlemen, please don't forget to subscribe and join to my YouTube community, and see you next in the next video. Please subscribe.